Hello everyone. Let's do another simple unit and complete that unit. I mean, previous day we finished the unit number 6 completely. We done and dusted that one. So I will start unit number 7 now. Unit number 7. It's about acids and bases, acids, bases and salts. Unit number 7. So I will try to explain all the contents in short time. You have to be attentive and pace you up and listen. Also try to understand what I say. If you have any problem or if you face any problem during the lesson, you can ask them in the Zoom meeting. Right, let's continue with acids, bases, salts. Acids, bases and salts. Right. First thing, acids. I will write with the relevant colors, then that's important here. There is an importance of writing this in these colors. Acids and bases and salts. Acids, bases and salts. So in three different corners I wrote this. First thing, let's check whether these things are or the differences and similarities of these things. They are chemicals, right? And acids, bases or salts, they are chemicals and compounds. They are chemical compounds. So when you take a substance, it basically substances can be classified into these three categories according to their the acidity or basicity. And if something is not an acid or something is not a base, it's a neutral substance. Salts are neutral. Next feature. When you think about an acid or a base, they comes into an action when we put them into the liquid media or the aqueous media. When you put them to the water, that's the next one. And I have one question to ask. Question is, do they harmful or not? Answer is a kind of pendulum answer. Harmful or not? Harmful or not? Sometimes they are harmful, sometimes they are useful. No. Some are harmful, some are useful. Some are harmful, some are useful. There are harmful acids, also useful acids. Also there are harmless acids that we can eat some acids. And bases also the same. Some bases are safe to use, some bases are harmful. Salts also the same. There are harmful salt types and useful ones. Usually mineral acids are harmful. Organic acids are safe to use. Right. Then let's think or let's learn how an acid gets these acidic features, or how a base gets basic features, and how salts gets its features. Basically, let's talk about the physical characteristics. Physically, how can we feel acids? Physical things, right? Acids are sour in taste, but the problem is some acids we can't taste. Taste is sour taste. Acids feel rough to our hand. Rough. There is a rough feeling when you touch an acid, right? Those are the physical properties. Then chemical features. Chemical features of acids. Acids can release hydrogen plus ions to aqueous solutions. They release hydrogen plus ions. So according to this, we can classify them as strong acids and weak acids. If they liberate complete amount, the whole amount of hydrogen ions to the solution, I'll repeat it. If they release the whole amount of H plus ions in it to the solution, we call them strong acids. If they release only part or the partially, if they release the hydrogen ions partially, we call them weak acids. Right? Acids are two types, strong acids and weak acids, according to the liberation of hydrogen. Now let's turn to this side, bases. Physical characteristics of bases, physical things. Bases are bitter in taste, bitter taste. Bases feel slippery to our hand. They have soapy nature. Actually, soap also a base. It feels slippery to hand. Chemical features. Chemically, bases dissolve in water and liberate OH minus ions, hydroxyl ions. We can classify bases also according to strong and weak. The ones which release the hydroxyl ions completely or the total ionized ones, partial ionizing ones. Strong and weak bases can be noticed. How a salt form. When an acid react with a base, then the result is a salt. I'm not going to talk about the chemical properties of salts here. I will state some physical properties. Salts are neutral substances, not acidic or not basic. When they dissolve in water, equally they release hydrogen or hydroxyl ions. If not, they never release hydrogen or hydroxy. I'll take one example and explain this. Sodium chloride is one of famous salt, but remember that is not the only salt exist. Sodium chloride is famous as the table salt, but look at this. When we dissolve sodium chloride in water, sodium ions and chlorine ions, sodium ions and chlorine chloride ions liberate. None of this can cause to make this an acid or a base because there are no hydrogens or hydroxyls. But there is a fact. When a salt is dissolved in water, water water molecules also break up, ionize. Water molecules also ionizes. H2O is the water. Water ionizes at S plus and OH minus. H plus ions and OH minus ions. Water ionizes. Sodium chloride ionized. Water also ionized. Now we can see one fact here. There are hydrogen ions, also hydroxyl ions. If there are equal number of hydrogen ions and hydroxyl ions, these two cancel out each other. That means it's just like positives, negatives, positives and negatives, positive charges, negative charges, north pole, south pole, likewise, right? There are two poles now. Therefore, if they are found equally, it neutralizes. Therefore, when you dissolve a salt in water, the medium is a neutral one. Physical chemical characteristics are discussed. We have to discuss how they change the indicators. In grade 7 you learnt about some indicators like the what we call litmus papers, pH papers, methyl orange, methyl red, likewise we have studied them. So using indicators we can identify them. I will take that as the next chapter. If I see the time now, it's 8 minutes past, and after around 20 minutes later we will start to discuss about the indicators, right? Now as I mentioned, this is the summary, and I want to show you how they ionize in liquids and also the chemical equations of those ionization reactions. But before this, I hope to bring you the show you small video. It's a kind of animation. Through this animation we can it's there are a few slides in this. Through this one we can understand, or we can take a kind of idea, I mean can make a summary about the facts that we learned. Mm, so I think this is ready. Right, watch this. Citric acid is a safe acid. That acid is found in, look at the features of this ionic compound. An ionic compound dissolves in water, forms hydrogen ions, I mentioned that, and sour in taste. And corrosive, not all, some are corrosive. Then the bases. Bases are also ionic compounds, forms hydroxide ions, slippery, bitter in taste, may be corrosive. Acids plus bases make salts and water. That reaction will be discussed later. Right. Hydrogen ions, hydroxyl ions. They are the ones here. And pH value is the next chapter. Then I will discuss about this one hereafter. Right. Let me show you the way that the way that different acids ionize in media. So I'll erase this the whole summary, or this is the introduction for our lesson. So let's erase this part and this part, but I will keep the topics same. Right. Acids, chemical reactions or the ionizations of the acids. Hydrochloric acid, HCl acid, one of famous acid in the laboratory. It's a mineral acid. When this acid is put into water, we will put AQ. As we add water, it will ionize as H plus ions and chlorine minus ions, chloride ions, H plus and chlorides. Both are in aqueous form, and it's very clear then ionization is full and none is remaining with this, no hydrogens remain with that. Complete ionization means a strong acid. It's a strong acid. Second, H2SO4, hydrogen sulfate, or the sulfuric acid. When it is in aqueous medium, H plus ions and HSO4 minus 2 ions form. There are 2 H plus ions formed here. 2 H plus. SO4 minus 2. Liberate the acids liberate the hydrogen completely, means this one also, this acid also a strong acid. There is another strong acid that we use in lab, that is nitric HNO3 acid. And in aqueous medium, HNO3 breaks up like that, hydrogen plus in aqueous medium and nitrate ions. Complete ionization, therefore a strong acid. So how would a weak acid looks like? Weak acid. This time I will take an example with different color here. H2CO3. This is called carbonic acid. Carbonic acid. It ionizes as this H plus and bicarbonate HCO3 minus. So can you see a difference in here than these ones? The difference is one hydrogen still stay with this, still stay with that. So only part of hydrogen released in this. Therefore, this is a weak acid. Is it clear? And these are the ones in your note. I will include them. You can write them orderly. Let's go to the next one. Bases. Bases types. First, let's take strong bases. Sodium hydroxide, NaOH, caustic soda, sodium hydroxide. Ionize as this: sodium plus plus OH minus, sodium and hydroxyls. And completely hydroxy is liberated. Therefore, it is a strong base. Strong base. Second one, potassium hydroxide. Potassium hydroxide, another strong base, releases potassium ions, K plus ions, and OH minus ions. Again, this time also it has removed or the released hydroxyl ions completely. Strong base. A weak base, NH4 ammonium hydroxyl. NH4OH. What happens this time? NH4 plus and OH minus. You may say that also has released hydroxyl completely. How can this be a strong or the weak base? But there is a fact we have forgotten. Fact is this: when you draw the NH4, there are three hydrogens completely bond with the nitrogen. One hydrogen stay as a plus one hydrogen. So that hydrogen gives kind of acidic nature to the solution, Therefore, this hydroxyls can't completely influence the solution. Can't completely influence because hydroxyls and hydrogen and hydroxyl, when you take this one, slightly the basic feature will be cancelled out due to the hydrogen ions. So this is a weak base. Now it's clear how those strong acids and weak acids form. Also, strong bases and weak bases are formed. And final topic, salts. How do salts form? It's really simple. If an acid meets a base, then forms a salt. Example is the first two. I will take these two: strong acid, HCl acid, react with strong base, sodium hydroxide. Then they will exchange their radicals. Chlorine and sodium makes sodium chloride, and this part is useless. And hydrogen and hydroxyl together form H2O or water. Sodium chloride and water forms. Therefore, sodium chloride is a salt, water is the other one. Both are neutral substances, as I mentioned in the previous part, and therefore this reaction is called a neutralization reaction. Acid can neutralize a base, or base can neutralize an acid. There are a lot of applications in the day-to-day. There are a lot of day-to-day applications of this one, neutralization. We can study that one when talking about the salts in details. Right. If you see the time now, 20 minutes past. I stated after around 20 minutes. After 20 minutes, we will start the chapter called indicators. The main indicator that I am focusing here is the pH indicator. pH papers. How do pH papers or pH indicator respond to these three? Let's do simple activity. I will go to that activity, or wait a bit. Wait, now I have prepared that place. Yeah, okay, not that. Here it is. There is something. Okay, right. I think you can see this. I will show you how these things work in here. I have kind of some water here, and we need to take an acid in this. Right, acid base and some other stuffs. First of all, I will show you the pH papers. pH papers. Let's bring this camera close to the activity site and also bend downwards. pH indicator. Universal pH comes like this type of yellow stripes. Let's take one stripe like this. Tear up into three pieces. 1, 2, 3 pieces. Because we will test three substances here: an acid, a base, and a neutral substance like water. Right, this is called spot tile. I will put three different acids in, three different substances here. So here are the substances. This is sulfuric acid, one of famous acid. Sulfuric will be put into this one. Remember the side that I put. This is the sulfuric acid. Then to other corner, this corner I will put a base. That is the sodium hydroxide. I will keep the sodium hydroxide bottle here and sulfuric acid bottle here and some water. There's a little rush, so we need to finish this quickly. As right, the middle one is water, just water. Now it is completely ready and set. So we need to turn the camera towards it. I have to adjust it a bit. So let's turn the camera onto that. Right, then you can see them: acid, base, neutral substance. Let's put the pH papers into this. pH papers, as there is an acid and mineral acid, especially we need to be careful not to put the hand into this. Therefore, I will take it with a kind of thing here. Then let's put this one and see the color change. I think you noticed it turned into reddish color, a kind of red color. We must watch this before holding the next, and I will put this one to the base, next one to base. Clear difference. Dark blue color appear, dark blue color comes then. Finally, wash it again and hold this paper and put this to water, pure water. And you may say that there is no change, but it is wrong. There is a change. Change is it turn into greenish color, green color. Now I dissolve it well here and remove the paper to this side. Then wash this, dissolve this well and remove the paper this side and wash it and dissolve this further. I think this sulfuric acid is not much strong enough. It's reddish pink color come. So it's very clear. The pH indicator turns green color in neutral indication and it turns blue color in more basic conditions. Acidic conditions, it turns kind of a red color or the red nature. And in pH papers, we can see kind of indication or the pH scale is there. I will show you the pH scale hereafter. Right. Then, after that practical, we identified how to check the acids and bases or the salts using the pH scale, pH indicator. The papers that we use there, those are the stripes, the dye-induced stripes. pH solution induced in them. pH is a solution, it's a liquid actually. So liquid is induced in that one. Right, 1 minute please. Okay. So hereafter, we can go to the next part. I mean, to learn about different types of indicators. But before this, I'll introduce the color changes of pH indicator. Again, we have to load a video here to see the color change of the pH indicator. I don't know whether I have loaded the correct one. Yes, this is the one. Right. Section 2, acids and bases. And right. Here's the indication. If it is pH 7, color is green and pH range varies from 7 to 1, 7 to 1 in acidic medium, like this. Light green, yellow, orange, reddish orange, red and dark red. So pH value, pH range is from 1 to 14 only. 1 to 14. 7 to 1, the 7 to 6 is acid, and 7 is neutral, and more than this, if it is greater than 7, it's a base. So let's see the range of the bases here: 8, 9, 10, 11, 12, 13, 14. So when it's increasing, you can see the bluish nature increasing. So dark blue means it's a strong base. That was the color that we noticed in the activity there. So you can see that activity, that dark blue color came, that means it is a strong base. Sodium hydroxide was used in that. Right, that's the difference between acids and bases. Acids and bases are different because of this one, and also using a pH indicator we can test it. The most important thing is, using pH indicator we can have an idea about the strength of an acid. If the acid is strong or weak, or more likely to neutral. With that colors we can come to an idea. So that's not the only indicator that we can use to identify acids and bases. There are litmus indicators, and also we can see phenolphthalein, methyl orange, methyl red. And the next video will explain us. We have 4 minutes to complete it within 30 minutes. So let's see whether we can do this. And this is about acid base reactions, acid base indicators, acids base indicators. Here in this video you can see different indicators are being tested here. Always here I will highlight, I'll explain this when it's starting. So you can see, when you see one side, I mean the, if you see the tiles or that spots in the left side, two spots are filled with acids, two spots with bases. One side acid, one side base. See how they change. First they are checking methyl orange. Put in methyl orange to acid, it turns pink color. In a base, it turns yellowish color. Yellow. Right, acids and bases change in the methyl orange. Then we take methyl red. It's red in acid, again yellow in bases. Red in acids, yellow in bases. Next we will take bromothymol blue, slightly yellowish in acids but bluish in bases. Bluish in bases. Right, next put in litmus papers. Litmus in acids, it's red, and this is pH, actually pH papers. Blue in bases, red in acids. pH indicator. That's clear. And litmus or the pH is the same type of term that we use for this. Then right, let's go to the next: phenolphthalein and indigo carmine. Phenolphthalein is a colorless liquid. When you put phenolphthalein, it turns whitish color in acids, or sometimes colorless in acids, but in bases nice pink blue, purple color comes, purplish pink color. That is the phenolphthalein, the change of the phenolphthalein in bases. Indigo carmine, when you put it into the acids, put in indigo carmine into the acid. Indigo carmine is not given in your syllabus or the book, but just we can have an idea about indigo carmine, bluish substance. You can see it turned dark blue in acids, but when you put it into the bases there is no color change. Sorry, it turns the yellowish color in bases. Right, this video is a nice video which explains the all the indicators. within 4 minutes we saw all the indicators and the changes take place. Right, and 30 minutes passed. I will take 2 more minutes for the summary. And acids, bases. Acids liberate hydrogen ions in solutions. Bases liberate hydroxyl ions in solution. Acids are sour in taste. Bases are bitter in taste. Acids feel rough. Bases feel slippery. When an acid reacts with a base, it creates a salt. Salts can be created by replacing replacing this hydrogen part of an acid by a strong metal or a base. These are the salts. Salts are neutral, and then indications. Uh, there is a reason to write these words in these colors. Now you can understand this. Acids give reddish colors in pH indication. Bluish bases give bluish color in pH indication, and salts give greenish color. But remember this pH scale is just line between 1 to 14. These days there is a post sharing among people by asking to eat some type of different fruits and vegetables or such things to prevent the coronavirus. If you carefully read that article, you can find in that article some pH values given, the pH values more than 14 are given. It says kind of nurse has written that one, not even a doctor. But even a teacher or even grade 11 student knows this. There are no substances which exceed the pH 14. I'm not going to explain the reason for this. For A-level students, it is taught actually. This is a log value here. And the per hydrate, pH means per hydrate. And I'm not going to take that advanced facts. But just remember, when you are reading an article or following such thing or sharing such thing with the friends in your groups, please concern whether the facts are correct. At least consider with your basic knowledge. Now you know that there are no substances which lines more than 14 pH, and also there are some things mentioned. Pineapple is a sour fruit, you all know that, but in that article they say its pH value is 11.4 or something. Can it be 11.4? If it is a sour taste one, sour taste ones are acids. Acids should lines below 7, below 7. So additional fact. So through these type of lessons we can add something to our general lives also. That's a summary of the lesson. And also you won't believe this is the end of unit number 7, and the unit number 6 extended for 5 weeks, but within one day we finished unit number 7. So we will beat with a worksheet. Not only that, also kind of I will upload the note after this. So thank you for joining me for this 34 minutes, and goodbye everybody, and have a nice week.